This week on the Superhuman podcast, we're here to talk about large language models. It's become a vogue topic that people want to know more about.
GPT-3 was the big splash, and I think there what happened was some of the research had moved along. Compute power was there, had been there for a while.
But talk me through your relationship with AI.
Why don't we take kind of the human knowledge at the time? There's a lot of statistical work being done by the folks who are playing online, right? So it looks at text that you have and it tries to figure out what is the next token. Not the next word, but the next token.
And at Superhuman, we did 89 million tokens last week.
Right.
I'm just geeking out because I looked at the stats this morning. 89 million tokens in. Kevin is the engineering lead at Plexure. With deep experience in computer and data science, today Kevin and I demystify language models, both small and extremely large. So sit back and enjoy. Kevin, welcome. Thanks for joining us.
Thanks for having me.
We're here to talk about large language models.
Yeah.
LLM, and everyone that listening will be familiar with that. I think it's fair to say that with the dawn of AI, or I guess the reimagining of AI a few years ago or 18 months ago, it's become a vogue topic that people want to know more about, learn about.
Yep.
And
everyone's talking about it, right?
Everyone's talking about it. So today I thought it'd be really good to lean on your expertise and experience and demystify language models, not just large language models, but small language models, and look at speed and performance.
Absolutely.
Etc. It's a conversation that we've riffed on before, and I thought it'd be really good to unpack it for everybody. So, talk me through your relationship with AI to begin with, and then we'll kind of just push into it.
Sure, yeah. Starts quite a while ago, back in the day of university, when finished my undergraduate, didn't know what to do. Thought, well, I guess I'll just keep going. I was playing a lot of poker at the time. I thought, you know what, I'll build myself a poker bot. That's what I'll do as my kind of master's degree. I'll find someone who's doing AI, and I'll build myself a poker bot. So went ahead and did that. Learned quite a bit, of kind of where things were at the time.
Roughly, when was this? What kind of time frame are we talking?
This would have been in 2012.
Okay.
Yeah. And kind of, I guess, focused a lot on the statistical side of things. Kind of what I was taking at the time was well before LLMs, and I guess more in the math side of things. Like the big thing was kind of Nash equilibrium bots at the time. And what I was taking at the time was going, how can I take one of those and make it better? Right? It kind of plays not to lose. It doesn't play to win. And so you could kind of guarantee that you would win, but it's not going to be by much. And, as any gambler knows, the point is not to win $3. The point is to win a lot of money. Mm-hmm. So why don't we try to get the bots to be able to do something similar? Why don't we take kind of the human knowledge at the time? There's a lot of statistical work being done by the folks who are playing online, especially, who are using kind of various mods with, say, poker stars to calculate a whole bunch of statistics to figure out when should I be making moves. And it's like, if we can't get this into an AI, we're doing something wrong. So, that's kind of what I focused on, is going taking kind of the knowledge of statistics that a lot of the pros were kind of using in the online space and kind of augmenting kind of, I guess, what was kind of state of the art on the mathematical side to win more.
Got it.
Yeah.
And at the time, so 2012, we're 12 years ago, they were bots, right?
Absolutely.
They were programmatically very good and rigid at certain tasks.
That's right.
Get to the notion of a predetermined outcome.
Well, so at this point, we were kind of doing some learning. We were taking an absolute ton of professional poker hands and running those through to learn and trying to achieve that, and playing lots of games, automatically to achieve that, what we'd kind of mathematically call a Nash equilibrium, where you are not exploitable by the other players. Yeah, that's kind of the intention. Yeah, and so it was a learning model, a simpler one.
Sure. And within those game tasks, chess was one as well. The ability to beat a human at chess that's not a new feat.
No, absolutely.
I mean, that's computationally, that's been the state for, and probably the last couple of decades now, in terms of the ability to look at a structured game that has rules and confines of the rule and create a technology that can outbeat it. But then you look at, how do you do that on mass for everything?
Yeah.
which ultimately, if you look at the bots around poker and around chess, you were looking at the corpus of data and knowledge around chess.
Yes, it's very, very specific.
Very, very specific.
And yeah, very, very focused. So yeah, on the chess side, when it was first, the first big game where everybody realized, oh wow, the grandmaster can be beaten by a computer. That was search, right? It's purely a search algorithm. I have this state of the board. I'm going to try to evaluate as many possible outcomes depending on what I can do, and I'm going to pick the best one. It's heuristic search.
Yep.
And they were able to get to it because at that point, IBM's kind of best computers were able to dig deep enough to get there, right? Before that, it was tried a lot with, experts in chess, professionals trying to put their knowledge into the computer, but it just didn't work, right? It wasn't until you could take that kind of completely human agnostic perspective and just go, we're just going to encode the game, and we're just going to do a search, and we're going to rely on the compute to go as deep as it needs to go to try and beat, people.
Which I think is the pivotal flip between how if you track that progress from humans creating logic to be able to train essentially a computer to do an agent's job or a bot's job.
Yeah.
We're no longer in that paradigm. We've now got essentially enough compute to be able to decipher the English language and all of the information that exists that's ever been written and or spoken and or videoed, and for the AI to fully now comprehend what that means and its relationship between the two. But ultimately, the whole notion of search and AI is the principles haven't changed. Like those are familiar with RAG, and we'll talk about some of the fundamental methodologies about AI in a minute. It's still detailed vector search and passing it through to a computational element.
Yeah.
But that notion still hasn't changed. So the principles are actually still very much the same.
Oh, absolutely.
But the amount of compute power is existentially bigger.
Yeah, even today's, large language models is a variation on a neural network, which is a concept from the 70s. If you look, if you do the kind of the educational side of AI, you realize that all these concepts, their birthplace was at the beginning of the computer age. Mm-hmm. And while we've definitely, riffed on it and we've improved it and we've mutated it to better serve the purpose, the bones are all from those early days.
Mm-hmm. So what's changed then now? So and I totally agree with you, the core concepts of where we're at today were principled 40 years ago, 50 years ago. Why in 2022 was the explosion of this, I guess, awareness of these principles?
Yeah.
In your view?
Well, I mean, there's a few things that came together. There was a number of research papers from quite a few out of Google that kind of started the transformer phase and adjusted kind of neural networks in that form of how do you actually train these things.
So people will be aware of GPTs.
Yeah.
That's essentially the line of the product description of what OpenAI bring to market in terms of their GPT-4 and or ChatGPT or custom GPTs. In terms of for the audience's exposure to GPTs, just explain the nucleus of what a GPT is from its core.
Sure. A GPT, I think the easiest way to think about it is it is completion, right? So it looks at text that you have and it tries to figure out what is the next token, not the next word, but the next token. And a token is essentially a split of a word in a way that a computer can understand it. Mm-hmm. And that's all it's trying to do is what's the most likely thing that comes after all the things that I've seen before.
Yeah. So we're talking, again, mathematical probability of predicting based on the knowledge that it's trained on what the next token is likely to be. Yep. And that concept is a GPT, a generative pre-trained transformer, which was essentially concepted a long, long time ago.
Yeah. Yeah.
And so the accelerant of that has been really access to compute power then.
I think so. It's been access to compute power. And I think the big one, right, GPT-3 was the big splash. And I think there what happened was, some of the research had moved along. The compute power was there, had been there for a while. But I think that's the first time where someone really was audacious and said, let's scrape the entire internet without any permission. Mm-hmm. And then let's just train on a massive amount of compute and see what we can do.
Mm-hmm. And that was a shared corpus of data that was known as the pile.
Yeah.
Wasn't it? You could download the pile. It was valid up until 2021, I think, the latest iteration of it. Obviously, that's changed slightly now. But you could go and download the pile, which was that baseline training data. And you needed, I guess, a few things. The Venn diagram was quite complex at that point. You needed access to the compute, access to the data, and then enough engineering power to basically
make it
plumb it together.
Yeah.
But Google released ultimately the first ever white paper in the modern age around this and going, hey, look, we've been R&Ding this and we've got something that's great.
Yeah.
We're going to go and push it out into the world. And they released that paper in 2017, I think, from memory. But then they got beaten to the punch.
Yeah.
Like, walk us through how you think that happened.
I mean, to be honest, I'm no expert in this area, but my assumption is just it's the data. That's kind of what made the difference. Is they weren't as ambitious with throwing quite as much data at this technique, because that's the real differentiator. The same thing with 4. What's the difference between 4 and 3? More data.
Mm-hmm. And where do you see the next evolution of that in terms of, if data has been the blood of getting the AI's competency up, the internet has been read and compiled and ingested. It's the biggest corpus of information that the world has is the internet, which contains all the literacy ever written, contains pretty much everything that's ever been documented. Where do you go when you run out of data?
Yeah, it's hard to say, right? I mean, you can try to generate. There's lots of AI that tries to augment itself by trying to generate feasible data that to then feed into training. I think there's quite a decent ceiling on what you can do with that. I mean, there's been a big push now that Reddit's data can be used by OpenAI. There's actually been quite a big push to push more people to interact with Reddit. If you Google or especially if you use Bing, one of the top results right after the ads is Reddit.
Yeah, 100%. And I think that's the part of the play that Elon Musk made with the acquisition of Twitter, formerly known as X, if you're explaining it how it needs to be explained these days.
Yeah.
But with X, you've obviously got access to essentially the heartbeat of the world's community. And Reddit's exactly the same. It's slightly more long form or medium form content. And the internet as a stationary corpus of data was kind of version 1.
Yeah.
Then you look at that almost live interactable data that's happening on social media platforms, and that allows AI to be up to date to the second about what's going on and utilize that for the purposes of managing its output. There is conversations happening around what this means for the corpus of video data that's on the internet, which I don't think yet fully have been ingested, like transcribing all of YouTube's content, for example.
Would be an enormous task.
I think it's underway.
Yeah, I'm sure it'll happen.
Yeah.
There's the desire there, and the compute's there, so given a bit of time.
Yeah. The interesting thing for me is that we're talking about publicly available information that's on news channels, social media platforms, and/or exists within the internet, which has been publicly published. Yeah. That's the whole notion of a website, right? You publish it to the world. Yeah. You publish your posts. Businesses have got intellectual property that is not published. It's within their own domain of knowledge.
Amounts. Yeah.
And huge amounts of that, which is considered their own IP.
Yeah.
What's your thoughts on how businesses take advantage of like the smarts of a large language model, but essentially I need to hand that over to an LLM or some form of AI service now to actually get the value of what AI can do for it, and the trust barriers where they exist right now, because it is definitely not grey. It's more black and white than it was a year ago. Yeah. But you are handing over the crown jewels to some extent. Yeah,
absolutely. And it is kind of the big topic at the moment because, GPT themselves, OpenAI themselves have made it available for you to put in your own knowledge base and start to query it and that kind of thing. And there's lots of businesses kind of jumping up around that space. But as you said, it's, when you talk to the customer, the biggest thing is, well, where does my data go? How's my data used? And how can you make sure that, that my data isn't being just trained and next time someone queries GPT about my company, it's going to start spilling, a whole bunch of our kind of personal data that we thought was just available to our employees. So I think there's still a lot to be done there in the trust space, but I can well imagine that there's a significant amount of, engineering and thought being put into it as well. And then it also strikes quite an interesting position in terms of, say things like GDPR, the right to be forgotten, right? That is a very easy, like at the moment, it's a much easier thing. You can it can be difficult to figure out where and who knows about something about you, but you can put in a request, and it's a very straightforward thing. Remove them from the database, whatever you want to do. How are you forgotten by an LLM? There is no going into, the LLM and changing some numbers, and all of a sudden they don't know about Dave anymore. That doesn't.
Because it becomes a cycle where you train on the base English and other languages to get the competency within the model.
Yeah.
So you start to remove data from the model. The model becomes less proficient.
Yep.
Then you need to start augmenting it with, well, you could do it through RAG, for example, vector search, to inject it into the model, which you've got more control over. But then you start to lose the inefficiencies of the model at that point, because you want the data in the model so the model's more powerful. Yeah. So it does become a cycle.
It does, yeah.
And then we're talking on models, and right now with the last conversation we've just had is around how do you throw as much data to the base training, and we're up to, I think, like Meta's model is 80 billion parameters, or
ridiculous,
crazy massive, crazy massive compute. But we've focused on large language models, which are highly competent across a huge corpus of information.
It's the general purpose tool.
It's the general purpose tool. Let's take a step down or around in terms of other types of language models and where they exist and what their place to play is. Starting, I guess, with like micro language models that exist on your phone. Just walk us through the different choices of models and where they exist in your view.
Yeah, I mean I think that's the interesting. One of the really interesting parts about this space is everybody focuses on those large language models, but as you start to work with them, so in the past I've built out a few functionality for different companies on large language models, and then quite quickly realized actually we don't need a large language model, right? We're doing quite a specific task. We have a good corpus of clean data here. And while, yes, an augmented large language model can do it, you can fine-tune a large language model, you can fine-tune a small language model. And you can pay significantly less, and you can host it yourself, and you can give your assurances to your clients. And it kind of easily gets around so many of these, I guess, barriers that we're still just trying to figure out how to approach. I think the big one for us in that was being able to say to a customer, your data is hosted here, it's run on our compute, it never exits, and there's nothing really to worry about. It's just like everything else, right? All of our other code, our database is everything else you trust us with. Well, this is the same. There's no addition here. And when you have a very specific task, you don't need anywhere near the breadth of that general purpose tool. And so often in business, the task is quite specific. Or you can build a pipeline of specific tasks that get you.
That'd be commonly referred to as an agent model in today's architecture.
Yeah. So I think there's a massive amount of value in those. And while they're, I think, not as well known, like broadly, I think in terms of business and especially the businesses kind of jumping up around AI, I think there's a fair bit of focus there.
Interestingly, I was listening to some content from the CEO of ServiceNow. You'll probably be familiar with ServiceNow, large software provider which is a business transformation stack, who've totally stepped away from the large language model approach. It's all about the small language model that they're building and engineering themselves, and they're leaning on OpenAI and Meta for the large language pieces of work, purely because, and this wasn't stated in the content, but there are only so many players that can put the hammer down on the extremely large models, right? Because of the amount of compute.
Yeah. I mean, just to have access to that amount of compute is well outside of most large businesses, to be honest.
Yeah, that's right. And to be clear for everyone listening, we're not talking about compute necessarily to run and host the models. No. We're talking about the compute to train the models, which is vastly different. You can run a very, very complex model on a relatively small amount of infrastructure, but you can't train one on a small amount of infrastructure. I mean, that's a huge...
But even running a large one, I mean, we looked at, what does it take to, like, at the time, what does it take to self-host like a Llama 2 and do some the cost there is very non-trivial, right? Like you have to be...
tens of thousands a month.
Exactly.
hosting fees.
You have to be very, and how do you get to the profitability that it takes to run that? Because once you kind of make that decision, you're running at a loss for ages until you can generate enough revenue out of that.
Yeah.
And for a lot of businesses, I think unless you're extremely financially stable, that's too big of an ask.
Yep.
Right? You can't start at that. You have to start small. Like you're either start saying, oh well, I'm just I'm going to pay OpenAI at an API call rate, or if I'm going to run anything in house, it's going to be smaller than that because it's too big of an ask.
And that's where the economies of scale become huge for these big players. I mean, the token cost and the economics of interacting with a large language model. How much do you put in?
Yeah.
How much do you take out?
Yeah.
And at Superhuman, we did 89 million tokens last week.
Right.
I'm just geeking out, so I looked at the stats this morning. 89 million tokens in last week, and you're talking like sub $500. It's but huge amounts of data shifting in and out on a token basis.
Yeah.
And actually, you really need to be shifting to be able to get to the cost parity of self-hosting.
Absolutely. Yeah.
Self-hosting models.
Yeah. The scale you need is intense. And then even once you get there, it doesn't work as well.
Yeah, that's 100% right. Yeah. So where do you think we go from here with, the GPT-4, Llama 3, Anthropic have just brought out the Claude 3 with Opus, which they're all really now fighting for the top peg of the most competent models. What does the next 12 months look like from your perspective?
It's been an interesting one because I think 6 months ago, I would have said to you, well, surely GPT-5 will come out soon. But now, I guess, having seen the lag time, yes, there's been obviously public outcry saying, oh, well, this is going to take over the world and whatnot. You have to stop, But I don't think that's going to stop a business from actually putting out the next tool, right? I think most likely is just the lack of data. So the real question is when does OpenAI feel like they have a big enough step to unveil? Maybe they haven't gotten there. How far away are they?
Well, they also are tapped out on. Okay, these are assumptions.
Yeah.
If you look at the data custodians, well, Google's the biggest one.
Yeah.
But I imagine a country mile in terms of data custodianship. And if it's not in a format that can be readily used by a large language model or trained, that's a process to get it. They own YouTube, they own Google, they own search.
Yeah.
They don't own social, which is arguably one of the pieces that's missing from the equation.
Yeah.
But OpenAI, they're beholden to Microsoft's, not beholden's not the right word, they have access and support from Microsoft to their corpus of information. But from that perspective, it's an enterprise data set, which is owned by the client. It's not owned by Microsoft.
Yeah.
So interesting to see whether there's actually more of a forking of capability. It's like, okay, actually it's not around the LLM right now. It's about LLM within timely, specific news. And it's LLMs within English and internet static data, and see whether they start to forge some verticals within the LLM space.
Yeah, I think it'll be very interesting to see kind of what the future holds. I think the only thing I'd say with some level of certainty is that nothing's going to take over the world.
Well, yeah.
I think
it's interesting that you look at the good use of AI, and we talked wholly about the good use of that technology to date. Just a bit about how do you use AI in a corporate working environment, and how do you take the good parts of the internet and have models that are well versed, all language, all scripture, etc. There's a dark side to email. There's a dark side to internet. There's a dark side to life. There's going to be a dark side to AI, and there absolutely is. I feel that the piece to be wary of is that how do people who are bad actors put this technology to use, because it's AI right now is exceptionally capable at mimicking humans.
Yes,
and therefore
I think
spam, phishing, all of that stuff is just going to get more.
I mean, we've actually seen it, right? So spam, it used to be that a big kind of red flag for spam was the grammar's no good. The grammar's no good in an email. Maybe consider it as spam. Now people are running it through AI, and the grammar's good. That's no longer really a red flag.
But interestingly, I was reading an article about the conversion rate, to use a marketing term, of spam.
Yeah.
And the technique that was used was people who were more susceptible to converting and actually handing over details would respond better to something that was grammarly incorrect. And it was actually that they were using AI to go, well, what's the best way to hook this person?
Yeah.
If it's too professional, you know.
Yeah, absolutely.
Like, well, if I'm prepared to click through on something that is subpar English, I'm far more susceptible to hand over my credit card details. And actually, the AI looking at the best ways to do that, it's not all about being correct; it's about converting.
Yeah, I mean, it totally depends on the space you're playing with, right? I guess the one I was thinking about is in the corporate side, where you're trying to do corporate phishing, you're trying to come across as maybe someone's boss or someone, there it does make a lot of sense. But yeah, if you're going after someone's credit card or someone's pension, then you're looking for essentially, I guess, some level of weakness or trusting that isn't deserved, and to exploit that.
Well, hopefully we see good overcome evil when it comes to the use of AI. It's going to be an interesting ride for sure, and it's obviously beholden on us in all of our different capacities to make sure that we engineer those solutions to be fit for purpose across everyone's use. But from a superhuman, in my perspective, I want to thank you, Kevin, for joining us.
Oh, it's been fun.
Really deepful, really insightful. If you're open to it, let's follow this journey and see where we get
absolutely.
to. And see if your predictions are right within the next 6 to 12 months.
We'll see. Yeah.
Thanks for joining us.
Cheers.